Right. Okay. Today we shall be looking at radicals and valency in chemistry. Radical, let's start with valency and then radicals. Radicals. Today is the 6th of January 2026. Radicals and valency. All right. You may be asked, what is valency? Valency is the combining power of an element. So the power of an element depends on the valency. So in simple terms, valency is the combining power of an element. That is what valency is all about. A valency is the combining power of an element. That's what we call valency. Alright, now the problem, before we talk about what we call radicals, the problem is how to identify the valency of these elements. That's a major problem. So if you don't know how to write the electronic configuration of some of these elements or this element, especially the first 20 elements, then the possibility of getting the valency of this element is not in view. So it's not possible for you to get the valency if you don't know how to write either common electronic configuration or modern electronic configuration. When we talk about common electronic configuration, we are talking about electronic configuration that has to do with KLMN. If you are talking about modern electronic configuration, then that is where we talk about SPDF orbitals. All right. So with time, we are going to get ourselves acquainted with both of them. But let's start with because that is the easiest way you can understand what valency is all about. So let's use the pattern of KLM shells. All right. Now look at this. We are told that the maximum number of electrons that are supposed to occupy each of the shells, because atoms, the maximum number of shells in atoms is 7 shells. That's why we have in periodic table 7 periods. 7 periods. So the maximum number of shells in an atom is 7. Like I said, that is why we have 7 periods in periodic table. All right. Now, be that as it may, now let's look at the pattern of KLM shell of writing electronic configuration. Now, the maximum number of electrons in each shell is given by the maximum number of electrons in each shell is given by 2n squared, where n signifies, where n is equal to the quantum number is called the quantum number. That's what n represents. N represents quantum number. So for you to know the maximum number of electrons in each shell, then this is the formula. Now, for example, look at this, so that you understand what quantum number is all about. Now, if you have, according to Rutherford structure of atom, that there is a central nucleus, then we have a shell, we have an electron revolving around. Now, we have, this is the first shell, this one is the second shell, this is the third shell, as you can see. Now, this one is the fourth shell, as you can see. All right, at your level, we might be stopping at fourth shell. So the first shell is called K shell, this one is L, this one is M, and this one is N. It continues like that up to 7 shells. Like I said, the maximum number of shells in an atom is 7, right? So now look at what this quantum number means. The first shell, that's shell number 1, this is shell number 2, shell number 3, shell number 4, 5, 6, 7. So all these numbers, they are called quantum numbers. That's what they are called, quantum numbers. So now, remember, according to this law, that the maximum number of electrons that each shell is supposed to occupy is given by this. Now, if n is equal to 1, so if n is equal to 1, that means the maximum number of K shell, the maximum number of electrons that K shell can hold is, you are using that formula to calculate, you have 2 into, in place of n, you put 1, so we have 1 square. So 2 times 1 square give us 1, 1 times 2, so that means this one will carry maximum electron of 2. Maximum electron of 2. While the next one, N2, we have 2 into 2 raised to power 2. So what is 2 raised to power 2? That's 4. 4 times 2, that's 8. So the maximum number of electrons shell number 2 can carry, that is L shell, is 8. Now we go to that of number 3 shell, that is 2 into 3 raised to power 2. So 3 raised to power 2 is 9. 9 times 2 gives us 18, right? Okay. Now the next one, which is number 4 shell, that's quantum number 4. We have 2 into 4 raised to power 2, and 4 raised to power 2 is equal to 16. 16 times 2 is equal to 32, right? But for some reasons yet to be discussed, it doesn't hold here. This particular law does not hold for the third shell. It does not hold for the third shell. The maximum number, instead of 18, the maximum number maintains 8, because at your level, your own is just the first 20 elements. So the maximum number, instead of 18, but the formula says that the maximum number of electrons that shell number 3 can carry, of quantum number 3, is 18. But it was proved otherwise, that the maximum number of electrons that shell number 3 can carry is 8. So take note of that. Very, very important. Very, very important. Right? So, be that as it may, now there are more for you to understand. Now, if they ask you now to write the electronic configuration of a particular element, let's look at now the first 20 elements. Let's look at now. So that is where we can be able to identify our valency, the combining power, what makes it combining power of an element. All right, okay. So let me clear the board so that we can forge ahead. All right. So now take a look at this. Now look at this. We want to start from the first 20 elements. Look at the first 20 elements. The first 20 elements now, we have the first one there as hydrogen. We are looking at the elements now. Elements. We are looking at the elements. Now the symbol. Then we are now we talk about electronic configuration. All right. Now the first 20 elements. Now this particular area, this side talks about what we call atomic number. That's what this side talks about. Atomic number. Now the first element there is hydrogen. That's the first element, hydrogen. What's the symbol for hydrogen? Is H. That's the symbol for hydrogen. Alright, the atomic configuration of hydrogen, since it's only one electron, only one. Atomic number is the number of protons. Alright, now there is what we call neutrality of atom. So when is atom said to be electrically neutral? An atom is said to be electrically neutral or stable when the number of protons is equal to the number of electrons. So now we know that number of protons is equal to 1. That means number of electrons is also equal to 1, because at this point the atom is electrically neutral, it's stable. So we assume, or we take the number of protons as also the number of electrons. So at this point, K shell will only, since we have only one electron, so K shell only, that's the electron configuration of this hydrogen now, just one, right? Now, the next one is what we call helium. Helium. We have helium. This is helium. Helium is He. Now, how many electrons? We have only 2, so that's it. That's it. The first shell occupies 2. Remember, the maximum number of electrons the first shell can occupy is 2. So that's it. Right? After this, we have what we call lithium. We have what we call lithium. We have what we call lithium. Right? Now, in this case, what is lithium? Lithium is 3. So we have Li. That's 3. So now, there's no way we can write 3, because the first K. Now look at it. Let's work with this. K, L, M, N, just continuation, O, alright, but at this point we may not reach O. Alright, now remember that the first shell, the maximum number of electrons it can carry, the first shell, the maximum number of electrons it can carry is 2. So we have 3 electrons here. Now, since this one cannot carry 3, so you put 2 first. Then the next one, you put it here. You can see. You put it here. You shift it to the next shell, because the K shell can only carry 1 electron. Is that understood? Alright, now the next one is 4. 4 is the beryllium. 4 is the beryllium. Beryllium, that is Be. Remember, we have 4 electrons here, now, which implies that the first one will carry 2. Alright, so you shift the remaining one to this point. Are you guys saying? So this L shell can carry as many as up to 8. The maximum number is 8. So you can be adding, except when it gets to 8. So it cannot carry something like 9. So remember that. Now, after beryllium, we have boron. We have boron. That is B. And this is the first one, 2, and you put the 3, the next one. Now, after that, we have what we call carbon. Carbon. So what then is carbon? Carbon is C, that's the symbol. We have 2. The next one is what? 4. The maximum number of electrons the K shell can carry is 2. Then the remaining one, shift it to the next shell, because this one can carry up to 8. Alright? So except you get up to 8, you cannot go to the next shell. Alright? So the next one is nitrogen. That's number 7. Nitrogen. Nitrogen, that's N. So remember, the first shell, K shell will carry 2. The next one will carry 5. Right? So after that, we have oxygen. We have oxygen. Oxygen is O. So we have 2. The next one is 6. So you send it to the next shell. Right? Then after which we have what we call fluorine. We have fluorine. We have fluorine. F. So we have 2 and 7. 2 and 7. Alright? So we have what next? What next? Neon. Neon. That's a noble gas. It's called a noble gas. I will tell you the reason why it is called a noble gas. So neon is Ne. So what does it mean? What does this mean? We have 2 and 8. You can see. This is the maximum we can carry. So the next one that is coming, which is 11, and that 11 is sodium. That 11 is sodium. So that's why we have Na. And we have 2 here. The next one is 8. Right? So out of 11, we pick 2. After 2, that's 8. So what is left is, now when we pick 2, what should be left is 9. So, but the L shell cannot carry up to 9, it can only carry up to 8. So you shift the 1 to the next shell, that is M shell. So the M shell of it now carries 1, right? Okay? So we have this. After sodium, we have what we call magnesium. We also have what we call magnesium. So magnesium is Mg, a symbol. Now we have 2, 8, and 2. So remember that M shell, the maximum also is 8. The maximum also is 8. So you continue to fill it, you continue to fill it until you get to 8. The one that make it 9, you shift it to the next shell, right? So that is how to write the electronic configuration. So I'm giving you an assignment or classwork to do that and send to my WhatsApp. All right, to complete it. Now, look at it now. Look at it now. The next thing now is how do you get your valency? How do you get your valency? Now, first of all, there is what we call valence electron. Take note of this. Very important. You might be asked, what do you understand by valence electron? Valence electron. What are valence electrons? Valence electrons are the electrons found at the outermost shell. Look at all these ones you found at the last shell. Like this one now, the last shell of this one is only one. The last shell of this one is 2. The last shell is this one. That's it. The last shell is this one. Alright? The last shell of this one is this one. The last shell of this one is this one. The last shell of this one is 4. This one is 5. This one is 6. This one is 7. This one is 8. That's the last shell. So the last shell carries electrons. So any electron carried at the last shell, it is called valence electron. Alright? Now look at this one now. This particular atom, its valence electron is 1. Here, the valence electron is 2. So the electron found at the outermost shell is what we call valence electron. But the problem is, now that you have known what valence electron is all about, then how do you identify your valency? Alright, now, any valence electron from 1 to 4 remains the valency. Any valence, I believe that you know what valence electron now is all about. Any valence electron from 1 to 4 becomes the valency. But from 5, I will show you. From 5 down to 7, it's not like that. From 5 down to 7, it's not like that. I will show you how to get the valency when the valence electron is more than 4. But as it stands now, what is the valence electron? The valence electron is, for this one is 1, the valence electron for this one is 2, the valence electron for this one is 3, the valency is 1, the valency is 2, the valency is 3, the valency of this one is 4. Including this one, the valency is 1, the valency of this one is 2. But when it is above 4, how do you get the valency? Now, how do I get the valency of this one? That is 5. Now, you think of which number will I add to turn this one to 8. How many electrons will I add to 5 to make it 8? How many? That is 3. So that's why the valency of nitrogen is 3. That's how to get the valency. That's how to get the valency. So in case they ask what's the valency of nitrogen, this is valence electron, but not valency. So the valency of nitrogen is 3. Now, what is the valency of oxygen? What will I add to 6 to make it 8? That's 2. So that's why the valency of oxygen is 2. Valency of oxygen is 2. Valency of oxygen is 2. If they ask what's the valency of oxygen, it's 2. Then that of fluorine. What is the valency of fluorine? What will I add to 7 to make it? What will I add to 7 to make it 8? The essence of adding to make it 8, when the valence electron is at 8, the atom is said to be in stable electronic configuration. In stable electronic configuration. When it is the valence electron is 8, just like this one now, is in what we call octet state. That is stable electronic configuration. So this type of atom does not react at all. It is neutral. It is in uncombined state. You can never see them combined. You can never, just like as you are having sodium chloride and chloride combining. So you can never see something like a neon chloride. Why? Because neon itself has a stable electronic configuration. Right? So I believe at this point you have known how to get the valency of elements. How to get the valency. These are the ways which you can get the valency of an element. So that is why we say valency is the combining power of an element. All right. So please, I would like you now to write from 14. That's your assignment. Make sure you post it to my. Let me see your performance. Let me see your assimilation. All right. So all you need to do is to write the remaining tonic configuration from 13 down to 20. Remember that this one will continue to increase. When it gets to 9, the one that will make it 9, you shift it to the next shell. All right. So I will be expecting your assignment. All right. All right. The next class we shall be looking at radicals and how to form compounds from these valencies. That's the most important thing. All right. See you next class.